Welcome back. I am your expert technical instructor. Today, we focus on a highly critical aspect of designing a testing strategy for pipelines, designing and implementing automated quality and release gates to ensure strict security and governance. In the realm of continuous delivery, velocity must never compromise stability. As organizations automate their deployment pipelines, they require sophisticated mechanisms to protect production environments from flawed software. This is exactly where designing and implementing quality and release gates becomes paramount. A release gate is a distinct, logical boundary within your pipeline, where the deployment process is intentionally paused. During this pause, Azure Pipelines automatically collects and critically evaluates a series of external health signals and governance metrics. Only if all mathematical criteria are successfully met does the deployment autonomously proceed to the next stage. Unlike traditional manual approvals, where a manager subjectively clicks an approve button, release gates represent absolute, data-driven automation. By integrating release gates into your deployment workflow, transformation teams eliminate human bias, dramatically reduce operational bottlenecks, and enforce rigorous compliance standards around the clock. This highly automated approach allows enterprises to scale their continuous delivery cadence to hundreds of deployments per day, without sacrificing the stringent oversight required for mission-critical infrastructure. This YAML snippet demonstrates the foundation of a release gate mechanism, configuring the pipeline to interact with an external webhook service to request automated quality validation before proceeding. The core logic of a release gate: a staging deployment pauses at the boundary to evaluate diverse health signals. Absolute success allows production deployment, while any failure immediately halts the pipeline. To effectively control deployments, engineers must understand the strategic placement of these validation checks. Release gates can be configured at two critical junctures: pre-deployment and post-deployment. Pre-deployment gates evaluate external conditions before any code is ever copied to the target server. These are heavily utilized for ITIL governance, such as querying Azure boards to verify that the corresponding release ticket is officially approved, or checking an external change management system like ServiceNow. Post-deployment gates, conversely, execute immediately after the artifact has been deployed to an environment, but before the pipeline considers the stage officially successful. Post-deployment gates are intensely focused on operational health monitoring. For instance, after deploying a microservice to a staging cluster, a post-deployment gate will continuously query Azure Monitor for a specified duration. If the new code causes an unexpected spike in CPU utilization or triggers excessive HTTP 500 error rates, the gate fails. This failure immediately halts the pipeline, preventing the flawed artifact from automatically propagating onward to the highly sensitive production environment. While gates are automated, this CLI command demonstrates how administrators can programmatically audit the status of pending pre-deployment approvals to ensure governance workflows are executing correctly. The dual-gate architecture. Pre-deployment gates ensure ITIL compliance before deployment, while post-deployment gates critically monitor system telemetry before allowing the stage to complete successfully. A profound use case for release gates is the capability to automate the inspection of health telemetry. Manual health checks are notoriously slow and prone to oversight. By integrating Azure Pipelines directly with Azure Monitor or Application Insights, teams can configure gates that execute highly specific Kusto query language (KQL) queries against live application logs. When configuring the gate, you explicitly define the acceptable operational thresholds. For instance, mandating that the average API response time must remain below 200 milliseconds, or that active security exceptions must remain at absolute zero. The release gate operates on a polling interval, repeatedly sampling these metrics over a defined period, such as 15 minutes. This stabilization period is crucial. It ensures that temporary deployment spikes do not trigger false alarms. By automating these health inspections, organizations build an incredibly resilient continuous delivery ecosystem that inherently protects itself, mathematically preventing cascading failures by blocking the release of any artifact that degrades baseline system performance. This is a basic KQL snippet utilized by an Azure Monitor release gate to count the volume of failed HTTP requests, ensuring operational stability metrics are strictly maintained. The health inspection polling loop. The gate initiates an initial stabilization delay, queries application insights, evaluates the error count, and iteratively requeries until stability is proven or the timeout expires. Beyond operational telemetry, release gates are the ultimate enforcers of project management governance. In highly regulated enterprise environments, developers must never deploy rogue code that circumvents the official planning process. To prevent this, transformation teams design requirements validation gates. These gates directly query Azure boards or GitHub issues to enforce strict logical conditions. For example, you can configure a pre-deployment gate that executes a work item query language (WIQL) statement to verify that all bug work items linked to the incoming artifact are officially marked as resolved, or that the parent epic has been formally approved by the business stakeholders. If a developer attempts to push an unapproved feature through the pipeline, the gate will detect the unresolved work item status and autonomously block the deployment. This seamless integration between Azure pipelines and Azure boards provides automated compliance tracking, ensuring that the technical delivery of software is flawlessly synchronized with the organization's overarching business strategy and auditing requirements. This WIQL query is embedded directly within a release gate configuration to actively search for any work items explicitly tagged to block the release, instantly halting unauthorized deployments. The governance enforcement flow. The pipeline queries all mathematically linked Azure Board's work items. If any required item is not marked as done, the release is immediately blocked for governance failure. Designing a testing strategy for pipelines is fundamentally incomplete without deep security integration. Release gates serve as the primary enforcement mechanism for security compliance validation. Before an artifact is allowed into a production boundary, a gate can trigger asynchronous security scanning tools, such as SonarQube for static analysis, or specialized container vulnerability scanners. The pipeline is suspended until the external scanner returns a cryptographic payload confirming that zero critical vulnerabilities were detected. Furthermore, for highly sensitive financial or healthcare applications, organizations use release gates to strictly enforce the Four Eyes principle. This principle mandates that the engineer who authored the code cannot be the same individual who authorizes its deployment. By combining automated security validation gates with strict, multi-tier manual approval policies, organizations achieve absolute audit traceability verification. Every deployment leaves an immutable, cryptographically verifiable ledger, proving precisely which automated systems scanned the code and exactly which human stakeholders authorized the final transition to production. While gates automate the process, this Azure CLI command illustrates how highly privileged service accounts can programmatically override or manipulate environment states during complex security incident resolutions. The high-security deployment model. The artifact triggers an automated CVE scan. If perfectly clean, the system enforces the Four Eyes principle by requesting an explicit managerial approval before authorization. While Azure DevOps provides numerous native release gate integrations, enterprise architectures frequently demand interactions with proprietary internal systems. This is achieved by utilizing service hooks and the highly flexible Invoke REST API release gate task. This capability allows your deployment pipeline to send an HTTP payload to absolutely any external validator. For instance, a gate might invoke an internal licensing server to verify that the organization holds sufficient cloud usage quotas before provisioning massive new server clusters. It is crucial to understand the distinction between synchronous and asynchronous validation in this context. A synchronous gate makes an API call and expects an immediate HTTP 200 success response to proceed. Conversely, an asynchronous gate sends a request and then gracefully enters a pause state, awaiting a distinct callback webhook from the external system hours or even days later. This advanced asynchronous architecture is vital for processes requiring prolonged data analysis, extensive physical hardware provisioning, or complex, multi-departmental security compliance reviews. This is a representative JSON payload that an external, asynchronous security validator would post back via a webhook to the Azure pipeline to officially satisfy and unlock a waiting release gate. The asynchronous gate architecture. The pipeline posts a request and enters a sleep state. Upon completion, the external system sends a callback webhook that seamlessly unlocks the pipeline for continuation. To summarize this critical topic, designing and implementing quality and release gates is the absolute key to balancing rigorous security governance with rapid continuous delivery. By strategically tuning timeout durations, polling intervals, and combining automated health inspections with mandatory security scans, transformation teams eradicate deployment anxiety. These gates mathematically enforce the rule that only flawlessly validated, highly secure code enters your production ecosystem. Please take a moment to like this in-depth video, subscribe to our technical channel, and navigate to quicktechie.com for unparalleled premium certification preparation. At quicktechie.com, you will unlock massive Q&A banks, brilliantly structured ebooks, complete audiobooks, interactive lab environments, and expert interview guides meticulously designed to propel your DevOps engineering career to the absolute highest levels. Thank you for your dedication to mastering these complex architectural concepts, and I am excited to explore comprehensive testing strategies with you in our next technical session. Utilizing the CLI to interact with release definitions enables enterprise architects to programmatically audit and standardize release gate configurations across hundreds of disparate deployment pipelines simultaneously. The formula for enterprise delivery, defining strict metrics, automating health checks, and relentlessly enforcing security compliance, ultimately yields a safe, high-velocity software delivery lifecycle.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.